Welcome to the Zeppeldar Commodore 64 Assembly Language Programming Tutorial Series, Episode 4. In Episode 3, I covered a method of creating a scrolling text window. In this episode, I cover creating a border for the program and adding some color into the mix. If the length of this video is way too long, I apologize in advance. Before I get started, I want to show off the review of my recently created video game, GPAC Dementia Defender. For those of you that are not aware, I created a Pac-Man style game for the Commodore 64, and it has been recently reviewed in Retro Gamer magazine, which is a magazine based in the UK, issue 167. So here it is. And this is the Retro Gamer magazine, issue 167. And if we jump to the back of the magazine, near the back, right past the homebrew section features, is the gaming reviews. And that is where you find the review of GPAC Dementia Defender, which got a 77%, and I'm excited about it, so it's pretty cool. And near the top here it says format Commodore 64, developer graydefender, and then it has a download link, and the price is free. And then the actual review is only a couple of paragraphs here, and there's a few screenshots, and so that's pretty much the review. I'm excited that it made it into the magazine, and in the next issue is going to be my interview, which I would show it on this video, but I don't have a copy of it yet, so that'll be upcoming. A lot of this particular video is me stumbling along, making mistakes, and later correcting some of them. If you find I'm moving along too slowly, don't hesitate to fast forward a bit and enjoy. Alright, in the last video we left off with being able to scroll the map and print the text on the screen at the same time. So, and now in a prior video, I believe in the first episode, or the first video in this series, I mentioned that we need to have some sort of a screen drawn here, and this is where I thought I would have the text portion display, and then I would have the map over here, and then maybe some statistics over here, game statistics. So to do that, we're going to exit the screen designer. We're going to make a copy of Zeph4 and start off with Zeph5. And paste in a copy. And I'll work with Zeph5 going forward. Okay. Alright, next I'm going to bring in some code that I copied from the PacClone project to draw the map. I'm going to call it draw map with ASM. And you'll see here it's using indirect registers, FB, FC, FD, FE. And it's taking it from the map low byte and the map high byte of the map data, which I don't have the map in here. So let's go through those steps to import the map data in here. Let's go into the screen designer. And then from here we're going to export assembler. And we're going to generate for all screens. We only have one. Don't really need the color data, but let's see what this does for us. Okay, good. So here's our screen data. We're going to copy and paste this in, or copy to the clipboard. Paste it in right here, and take this out. Let's make this a quick little program. JSR it to call it, return, and let's see if that compiles. There it is. So when you run it, it draws the whole map. Now, we didn't pull in the color data yet, and I haven't used color data in any part of this project yet, and I'm going to do a little bit of that in the segment following this. But I'm not satisfied with the way this program runs. It runs fine, but I want to rewrite it a little bit to not use the indirect registers. Now, what you'll see, what it's doing here, it's loading X with the value of 4, loading Y with 0, and then it's looping through all 255 positions in Y, indirectly referencing the map data down here, map low byte, map high byte. So it's loading from the map low byte, high byte, storing it to FBFC, which is defined as 0400, which is the screen data, the map position on the top left portion of the screen. And then for every 255 characters, when it's done, it increments the high byte of FC and the high byte for FE for these two references. And here it decreases X. It's just a short little way of doing it. Actually, it's kind of clever. Let's try it a different way. Okay, so FDFC. This will be our map data. Here. Okay, and so I'm going to give this a label. I know the label above says loop 1. We'll call this screen data. And instead of incrementing FC here, we'll increment screen data plus 1, plus 2. Which is the high byte. So to increment that 0.4 to be a 0.5, we'll increment that. And then here, instead of FE, we'll increment loop 1 plus 2, which is the high byte of this. But we'll have to set these up here. And that's what this portion here was already setting things up. So here we're loading the 0, storing it in FB. Instead, we're going to store it in loop plus 1, loading the 0.4 and storing it in FC. Instead, we're going to store it in, that's loop 1, loop 1 plus 2, and then loading, here we're loading the X register for the low byte. All right, here we're just going to essentially copy what we're doing here. And we'll comment this out by highlighting it, right-clicking, comment, and what we'll do is we'll say load map data, the low byte, store it at loop plus 1, load the high byte of map data, store it at loop 1 plus 2. So now we've, oh, hold on a second, I did that wrong. So map data, loop 1 here should be screen data. So I messed that up. SCR data, and this one here, SCR underscore data. So 0400 is the screen data. This is the map data. Okay, I don't need this anymore. Let's run that. So apparently that didn't work just right. Let's figure that out. So let's put the hashtags in here and here. So you want the actual value, not the memory address of those. And then run that. Okay. I prefer that as opposed to using the indirect references. I also think it's faster this way. It's using self-modifying code, but that's the only down part. But I like this better. Now, if we really wanted to clean this up a little bit more, we rename these variables. But the next step from here is to take the draw map routine and then copy and paste it into the actual program that we created, Zef5, and integrate it in there. But before we do that, let's rename these variables. So loop 1, we'll just do a search and replace. And we'll call it map game map 5 occurrences. And that's really all there is to it here, so probably could format it. In CBM Program Studio, it gives you the ability to reformat your code here by going to the Edit menu, Reformat Code. And then you can set up your spacing. And so let's just take the defaults and hit OK. And so if you do that, it does a fairly good job of tightening out your code, aligning everything up. And then when you hit Enter at the end, it will line those up in the right spot. Copy draw map and the map data. We don't even need these two variables, huh? End up not using them. And let's run that again just to be certain. Okay. Save. Copy. Bring it over to Zef5. And we just got to find a place to put it. Let's put it here. So we got our draw map routine. And we'll want to call that near the top of the program. So after the clear screen, probably after you could redefine the character set, JSR call the routine to draw the map. Now I know I haven't made the adjustments yet to move the map into the proper locations, but let's just see what it looks like. Okay, so you get the idea, right? We just got to move the map over a little bit and the text where it's drawing, and we're well on our way. Let's do that next here. In order to move the playable map down to the right location, what I'll have to do is I'll have to record the new position. Right now, the map is assuming that you're at position 00 on the screen. And so we need to move it down instead of 400, which is where this is, this top left corner. It's inside 1 over here, down 1 over 1. And that is position 429. And because of the way I wrote this program, there isn't a variable for the position X and Y. I just hard-coded the positions. And so because of that, these values right here have to be updated. So this is a table starting at 400 going and then adding 40 for each one. So 400 plus 40 is 428 hex. Plus 40, another 40 a decimal is 450, and so on. It goes all the way across. So in order to shift the map, those values have to be updated, which I have already done in this table down here. And I'm going to comment out the old values. And by doing that, now the first position is 429 in hex, and then I add 40 to each one all the way down the line. All right, so let's try that now. I'm going to press F5 to compile. Now this is just shifting the X and Y position, the starting position. So now you see the map is shifted over and down one. I haven't changed or increased the height or the width yet. And I haven't moved the text down here yet either. So those are the next things that I have to adjust here. And then in order to make the map wider, I'm going to have to come up with a new map. This was just for testing. And I don't, you know, this whole thing is kind of for testing, but I need to come up with give it a better example map. And I'm going to do that here in the next segment. Expand this map, the width and height, and redesign the map a little bit just to make it more interesting. Alright, so I changed the width to 20 and the height to 16 on the constants here. Let's see, it was the width of the viewport on viewable on screen. Now I also need to update this, the game map data. It used to be 40, still 40, but now I've made it 16 also. Let's just see what that does. Oh, I see. See, my text here is in the wrong spot. I need to fix that, but it's starting to look a little better, a little more interesting. All right, let's see. I think, oh, I went one too far, didn't I? Let's see what the actual map looks like. Yeah, I went one too far here. So let's fix that. I didn't even notice that at first. Let's go, oops, not this one, but 19. There we go. In a way, even without the color, it's starting to come to life. Now I gotta move the text here. It looks like this has to move down 1, 2, and then back. 1, 2, wait. 1, 2, 3, maybe 4. So in order to move this little text window, I know it's not ideal, but we have these here in the shift window. 1, 2, 3, 4. So I'm going to add 2 to this, make these 17. I could probably make these, easily make these constants, but for now, they're not. And we're going to make 5, which is the X position, make that a 1. And see where that places that window when we recompile it. So there we go, okay. We can actually make the window taller if we wanted to. Or this one, so it fills up. We got 2 more characters we could use. So let's make it 7 here on the height. And recompile it. Oh, now it's too far down. Or we have like a slight issue here. On the code. Let's make it 6 and see what happens. Yeah, so it's probably got 1 extra character where it's going down to the next line. But for now, I'm just going to leave it like this. I'm not trying to make this bulletproof yet. Alright, the first thing I want to do here is add some color to the water. The water's already blue. But if we wanted to change the color here, I'm going to need to modify this movement routine section. And so where it's loading from the game map a character and then storing it on the screen, I'm also going to need to store a color value in that same position. So for now, I'm just going to give it a dummy address, which is in the color range of the screen. But I'm going to call it output color. Give it a label, and then set it up here is what I'm thinking. Where this is setting it up. But before I can set it up, I actually have to set up some more variables here. So there's this array here, the constant screen low, the constant screen high, which is the hard-coded positions of where the screen is loaded. I at least need the high byte, so I'm going to go constant color high. And we'll make these D8. Instead of 04, we make them D8. Now, what I could do is just do the addition, and we don't need this. And it comes down to performance. And it D9. So yeah, if it's fast enough, I might switch this out and just do the addition. So you can add, instead of having another array, you could just take this array 04 and add D4 to it, which makes this D8. So I might end up doing that. Reposition my window. Okay, constant color high. Now let's go back to the main loop. Constant color high, but we'll use the other one. And then instead of output here, it's out color +1, out color +2. And that will set up this high and low byte. But I'm not going to STA, that color, I have to load a color value here. Now if I just load a number like 1 or 2, that will change the color of everything. But so let's just see proof of concept here if what I just did worked at all. Compile it. Okay, you can see we have some problems. It made it white, but it didn't do this bottom row here. So I may have had a mistake in my constants here. Let me see. D8s, D9s. Yep, I had a mistake here. D8s going across. This is D4. D04 is the screen color, and then D8 is the color. When I hit the 05s, this is supposed to change to 9. And then when I hit the 06s, this should be an A right here. Which means when I hit the 7s, this should be a B. If I had done the addition, this wouldn't have been a problem. If I recompile this, it should have a white map. Yeah, cool, right? Now let's change it to 2. I think that'll make it red. Yeah. What you really want to do here is stuff a routine in between here, like to compare the character that's being loaded. Like I want to say compare to a 0. If it's equal to a 0, you make it whatever color you want. The 0 being water, the water character. And if it's not equal, so let's say, let's just kind of put a label here. Watercolor. And if it's not equal, then we load another value, like make it white again. Let's see. Let's make it the water white. And let's load a different value. Everything else red. Just to get it working. But ultimately you would make this a routine. If it's 0, you make it white. Otherwise it's red. Let's try that. Oh, 0. 0 is black, okay. And everything else. Yeah. So land is white, water is red. Okay, so instead of putting it inlined right here, what we want to do, strip this out and do some sort of subroutine. Jump sub get map color, something like that, you know. So it loads the value into the accumulator and stores it right after that. So let's find a place to put that. Maybe down here at the end. Control V, paste it in. Get map color. At the end, you do an RTS, and then it needs to be structured a little bit better than this. So you compare it. So you're passing down a value in the accumulator here, and then you're comparing that value. It's the character that it's on. So if it's 0, it's water, and we have to kind of define what these characters are. whatever. Let's say we wanted those O's to be something. If you want the colons to be something, we have to figure out what those color values are, what those numerical value for that character is. And that's what the comparisons are right here. So 0 I know is the @ sign, or is the water, which was redefined. And you have a bunch of them. Compare it to, I got to figure out what the color values are, or what the number character values are. So for now, I'm just going to put something in, branch if equal, compare it to something else, branch if equal. And then you could default, we can make the default here I guess leave that one in. Make the default number 1, for example, red, and then return. And then, so here we got the watercolor. Here we could put land color. And here we could have one more, just for example, object or something like that. Object 1 color. And we got to change the colors. And just kind of go up the numerical scale here. So you got water is 2, the next one's 3, 4, for example. So now I got to fill in what these are. And I think the easiest way to do that is to quickly go into the screen designer and look for those characters. I used colon. Let's see if I find colon. 58, and I used the letter O. So 58 and 15. So let's go here. 58. 15 before I forget. 58 is the colon. Just call it. Oh, I already have it. Land color. And we'll make this one object 1. Oops. I say I have object spelled wrong down there. Okay. Let's compile and see if that does anything. Now it looks like the O's didn't work. The pluses are white. That's kind of a, let's adjust the colors here. Let's change the default instead of 1 to be 8. Just see what that does. Okay, so that's that. The plus sign, I think, is what that is, what that affected. And let's change these color values. Let's reduce them. 1, 2, 3. See what we get. All right, yeah. So I think this is well on our way here. The color values, looking at the screen designer, here's your colors. 0 is black, 1 is white, 2 is red, 3 is cyan, and I had 8 is orange. So you could define all those in constants to get your colors, like instead of putting the hard-coded values here. We can create some constants. Make it 1. Oops, woat. let's just kind of start with those black and white. I didn't use black, did I? And let's just see if that works. So the water is white. Good, good. Let's make the land a different color instead of, I'm not even sure what 2 is. Red, I think. Let's make the land green. Make it maybe 5. I don't think you need the hashtags here. I could be wrong. Let's try that. Oops, I didn't put green in there. You do need the hashtag, but not, you can do it down here. And land constant green. So I got white water, green land. Let's see if that works. Yeah. So I mean, you can use your imagination, let it run wild here. So see, as I go here, we have the bug down here where it puts a blank line. But I mean, that's part of the process. All right, so there's a number of ways we can go about coloring the text here. We could either fill in the colors with a quick loop that just fills in these 4 or 5 lines right here. We could change the cursor color and paint as we draw the characters in. There's a problem with that, as you can see, because once the color here is for north is blue, but the way I wrote the program, it scrolls the text up. It's not scrolling the color map values with it. So that's a problem. So it depends on your design. If you need different text colors to show up here, you're going to have to design a little differently. You're going to have to come up with a different way of doing it. What I think I want to do to fix the color values in this box is go back to the screen designer and just recolor them in. And that way I don't really have to worry about it. It's a simplistic way of doing it. So in the screen designer, you click recolor and then select your character color. I was going to go with white for now. I don't know, maybe I can go with another color, but white, I guess, or yellow, either one. Then you go into each box and you click into each one, that color value. It's hard to see here because there's nothing in there. But say if we go up here and do the replace and change the space, which is a 32, and change it to like the letter G, which is a 7. And you can see where the spaces are. And then we can go in here and recolor. So now it's yellow, you know it's yellow. We're going to go up here, replace 7, put it back to a space, which is a 32. And now these color values down here should be all 7. And you can see it down here where that color is. It's all 7s in there. Now I'm going to save, click save. But when we export assembler, we're also going to generate the color data here. So we got it. You have to have that checked to include the color data, and hit OK. So yeah, this takes up a little bit of memory. So here's your screen data first, and then here's the color data, and those are all set up in your options. You could have selected them. There's a few options to change how this data gets presented here. So I'm just going to highlight that, copy, and then close this out. And then we'll go back into the program where the map data is, and we'll put the color data right behind it. And we'll have to format that so it lines up. But we'll call it map color if that's not already being used. And then we have to modify the draw map function to include the color. As it's drawing, I have to do this a little differently. I have to load basically the map data down there, the color data. So I got to put a bogus address here and then store it at the D800 as it's going. Now I got to give this a label. Color map. And it's this portion I want to copy. Map color. And color map. Color map +2. And then as it's going, every time it increments, we also have to increment the color map +2. Okay, so now we have the color there, but because I'm using FFD2 function, that's why you don't see the yellow right here, because the way the program prints the text, it uses a function that gets its color from a different location. So let's fix that. And I'll take you to the color map, the Commodore 64 memory map. So we're going to use this address 286 to set the cursor color, and we use yellow, right? So yellow is 7, and this is the loop that displays the text. And I don't know, let's see if we can just put it up here. Load a 7, and we can make that a constant. Store it at 286. If that works, I'll make the constant. And that should make the cursor yellow. There we go. So we can do a constant for yellow. So it comes down to the design, and sometimes you decide, oh, I'm going to do it this way, and then you come back, oh, if I do it that way, I can't do this, or Now, I did blow away my gray border, but I liked it, so I'm going to bring it back in. So let's go to the Screen Designer, change it to the light gray. oops, Control Z. We want to recolor. Okay, so now I have the whole thing gray, but I need to export the color data again. I'm going to save it first. Export assembler, include the color data. And you can see I have these options, generate empty rows. And really for now it's not important to understand what all this means. And you can change the order, color data first or screen data first. These are the options I was mentioning earlier. And then just replace. This is kind of what I was doing, or exactly what I was doing in the pack clone game to do the color. But the color, having the different color, if you have a bunch of different maps like this, it can get really expensive on memory. It takes up a lot of memory. Okay, now let's see if we have a gray border. Gray border, text yellow, we've got some color up here. Alright, did you notice the bug that I introduced? I was totally oblivious that the greater than sign was missing, and I didn't notice it until the next day. So anyway, this was a relatively easy fix. So let's take a look at what caused that. And so earlier in a previous segment, what I was doing was I was repositioning the variables for the screen to move the map on the screen. Well, not realizing that there was another part of the program that was using the old positions. It was assuming the old positions were still in place. So I need to somehow restore those back. And I know there's probably a better way of coding this, but this is what we have. So I need to rename these, restore them in, and then replace the part in the program where it's using these variables here. And that is where it scrolls up. Oh, there it is. Scroll up. Change these low to low. To low. That should be it. Okay, so now I have my greater than signs back. It fixed that problem, and it also fixed another problem. Now I have one more line, which I didn't even realize was missing. So I need to reposition this down one. The text that's displaying, I need to position it down one. And because I don't have those in constants, this is why you use constants. You gotta hunt for it. So this is X position, Y position, width, and the height. And we want to go down one. I'm going to make the 17 to 18. And recompile it. And that should fix the problem. Let's see. Alright, so at least now it's doing what I think it's supposed to do. The color is not right on that position right there. That could be the map. I'll have to see. Let's see if it's in the map that way. Color 7, color 15, yeah, so that just has to be recolored to be a 7 right there. Control V. Now when we run it, that position in the corner should be yellow. There it is. So, alright, that's a quick little bug fix. About 3 bugs in one for you.